Welcome. In this video, we'll explore slope and y-intercept, the building blocks of linear equations. You'll learn about different types of slope, how the y-intercept shifts a line, and how slope shows if lines are parallel or perpendicular. By the end, you'll be able to graph any linear equation with confidence. What is slope? Slope is a measure of how steep a line is and the direction it moves on a graph. It is defined as the ratio of the vertical change to the horizontal change between 2 points. This is often described as rise over run. The formula for slope is m equals y2 minus y1 over x2 minus x1. Let's calculate an example. If the rise is 2 and the run is also 2, then the slope will be m equals 2 over 2, which is equal to 1. This means the line goes up 1 unit for every unit it moves right. Next, we'll look at the four main types of slopes you'll encounter. First is the positive slope. The line rises as you move from left to right. For example, the equation y equals 2x plus 1 has a positive slope of 2. Next is the negative slope. The line falls as you move from left to right. For instance, y equals negative 3x plus 2 has a slope of negative 3. Then there's the zero slope. The line is perfectly horizontal, like y equals 4, meaning there's no vertical change as x changes. Lastly, there's the undefined slope. This occurs for vertical lines such as x equals negative 2, where the run is 0, making the slope undefined. On the screen are some examples to visually show you the differences between the different types of slopes. Let's practice calculating slope using 2 points. The slope of a line shows how much it rises or falls compared to how far it runs, often described as rise over run. Suppose we have the points 1, 2 and 3, 6. The run, or horizontal change, is 2, while the rise, or vertical change, is 4, meaning the slope is 4 divided by 2, which is equal to 2. We can also check this by using the slope formula. M equals 6 minus 2 over 3 minus 1, or simplified, 4 divided by 2, which is equal to 2. So the slope of the line passing through these points is 2. This means the slope is positive, and for every 2 units the line rises, it shifts to the right 1 unit. Slopes also help us identify relationships between lines. Parallel lines have the same slope but different y-intercepts. Because their slopes match, they never intersect. For example, the line y equals 2x plus 3 and y equals 2x minus 1 are parallel lines. This is because they both have a positive slope of 2. Even though they're on different parts of the graph, they maintain the exact same steepness and direction, so they'll never meet. Perpendicular lines have slopes that are negative reciprocals of each other. That means if one line's slope is m, the other line's slope will be negative 1 over m. For example, a line with slope 2 will be perpendicular to a line with slope negative 1/2. When two lines are perpendicular, they intersect at a right angle, or 90 degrees, which is a key property in geometry and graphing. You can often spot perpendicular lines by checking if the product of their slopes equals negative 1. Next, let's try our first practice problem, finding slope. Practice problem 1. Finding slope from 2 points. Find the slope between the 2 points 2, 5 and 4, 9. Pause the video and try this yourself. First, it's always helpful to visualize these points on the graph. As we can see, the slope will be positive due to the y value going up as the x value increases. Next, to calculate the slope, we use the slope formula. M equals y2 minus y1 divided by x2 minus x1. This formula tells us how much the y value changes for every unit the x value changes. To solve our problem, we want to substitute the values, giving us the equation m equals 9 minus 5 divided by 4 minus 2. Simplifying the numerator and denominator gives us the equation m equals 4 divided by 2. And using our knowledge of basic arithmetic, we have our answer, m equals 2. So, the slope of the line passing through these points is 2. Remember, when finding the slope between 2 points, always subtract the y values and x values in the same order, y2 minus y1 over x2 minus x1 to get the correct result. So, let's discuss the y-intercept. What is the y-intercept? The y-intercept is the point where a line crosses the y-axis. This happens when the value of x is 0, in other words, it's the starting value of the function before any change in x occurs. We can find the y-intercept from an equation by plugging in 0 for x and solving for y. But first, let's visualize the y-intercept. Consider the point 0, 1. This means the line crosses the y-axis at y equals 1. If we shift the line so that the y-intercept changes to 0, 3, the entire line moves up, starting now at y equals 3 instead of 1. Similarly, if the y-intercept shifts down to 0, -1, the line moves down, crossing the y-axis below 0 and at y equals -1. Adjusting the y-intercept moves the line up or down without changing its steepness or slope.
Practice problem 2. Identifying the y-intercept. Given the standard form equation 3x minus 2y equals 7, and the point 2, 1 that lies on the line, what is the y-intercept? Pause and think before continuing.
To better understand this problem, let's first visualize the line on a coordinate plane. The line passes through the point 2, 1 and is represented by the equation 3x minus 2y equals 7. Next, we rewrite the equation in slope-intercept form, y equals mx plus b, which makes it easier to identify the slope and y-intercept. This gives us -2y equals -3x plus 7. Dividing both sides by -2, we get y equals 3/2 x minus 7/2. From this form, the y-intercept is clearly a constant term, -7/2 or -3.5. Next, let's look at a real-world example. Imagine a taxi service charges a flat fee of $3 plus $2 for every mile traveled. If you travel 5 miles, what will be the total cost? We can model this with a linear equation, y equals 2x plus 3. The slope here is 2, representing the cost per mile, and the y-intercept is 3, representing the starting fee. If you travel 5 miles, the total cost is y equals 2 times 5 plus 3, or simplified, y equals 10 plus 3, which then you add them together and you get y equals 13 as the total cost. We can also check our answer by looking at the graph and making sure the point 5, 13 lies on our line. Understanding slope and y-intercept makes solving real-life problems like this much easier and more intuitive. It helps us quickly break down how costs or quantities change and predict outcomes without needing a table or long calculations. For the last part of our video, we'll do a challenge problem about parallel and perpendicular lines. Consider the lines y equals 3x plus 2 and y equals 3x minus 5. Are these lines parallel, perpendicular, or neither? What would be the slope of a line perpendicular to y equals 3x plus 2? Pause and think about these questions. For the first part of our question, asking whether these lines are parallel, perpendicular, or neither, we have to look at the slope to find the answer. Looking at the slope, we can see that these lines are parallel because they both have the same slope of 3. Even though the y-intercepts are different, 2 and -5, the steepness of each line is identical. Since parallel lines never intersect, these two will run side by side forever without crossing. You can spot parallel lines on a graph because they never touch, no matter how far they extend. Next, a line perpendicular to y equals 3x plus 2 would have a slope that is the negative reciprocal of 3, which is -1/3. Perpendicular lines meet at a right angle, which happens when the product of their slopes is equal to -1. On a graph, perpendicular lines form a perfect L shape where they intersect. Now, let's summarize what we learned so far in this video. Slope shows the steepness and direction of a line, while the y-intercept tells us where the line crosses the y-axis. Parallel lines have the same slope and never intersect, whereas perpendicular lines have slopes that are negative reciprocals, forming right angles where they meet. Understanding these concepts is key to graphing and interpreting linear equations accurately. With practice, it all becomes easier. So keep at it, and if you found this helpful, don't forget to like and subscribe.